Welcome back to Water Quality in the Pacific Northwest. This is Soils 404-504 this fall semester. Today we're going to continue to talk about groundwater quality. The first groundwater quality lecture was just an introduction to some of the groundwater quality issues. And yesterday, or in lecture 5, we started to talk about nitrates and why they're indicators as far as water quality is concerned in groundwater. Today we're going to continue our discussion on nitrates in lecture 6 and present you with a little bit more data about nitrate areas of concern and some of the history here in Idaho about nitrates. Let's start out and talk about what is our database. What do we know about nitrates and groundwater, in particularly in Idaho? Well, first of all, we have a really good database in Idaho. There was a survey done in the 1990s. This survey was led by the Idaho Farm Bureau. The Idaho Farm Bureau had contacts with rural landowners across the state, and they brought in other agencies to partner with them. A monitoring program to make sure the QA/QC was correct was initiated and developed by the Idaho Department of Environmental Quality, the Idaho Department of Agriculture, and the Idaho Department of Water Resources. The health districts were involved where the samples were taken. And we've got a really good historical database on nitrates because of this Farm Bureau well survey. This Farm Bureau wellhead survey was conducted between 1990 and the year 2000. And it was done on a county-by-county basis. 27 counties in Idaho participated in this survey. And the reason for the 27 counties is that the Farm Bureau developed this idea and it asked its local Farm Bureau representative to put together local steering committees to see if the local county actually wanted to participate in the survey. And 27 counties actually took part in the survey. The amazing thing about this survey is that over 2,700 wellhead samples were collected. So this is 2,700 well samples from individual owners across the state of Idaho. They all came from private wells. This is a huge number of well samples, something that an agency couldn't have undertaken, a public agency could not have undertaken. Because you needed access to get on people's land. The Farm Bureau survey, the Farm Bureau, being part of the local community, had much easier access to private land. The last of the 27 counties that was collected was in Gooding County in about the year 2000. I'd like to take a look at the results of the Idaho Farm Bureau wellhead survey, and that's what we call it, the Idaho Farm Bureau wellhead survey results, and talk about what do the numbers mean. Well, basically, first of all, remember we have an EPA standard of 10 parts per million nitrate nitrogen. If the wells contain less than this 10 parts per million nitrate nitrogen standard, the water is considered safe as far as nitrates are concerned for all people to drink. If the nitrate nitrogen value is above 10 parts per million nitrate nitrogen, it's considered not safe for infants. The survey results showed that of the wells that contain more than 10 parts per million nitrate nitrogen, only 6% of those 2,700 wells contain nitrate nitrogen levels above the EPA standard. An additional 15% of the wells contained between 5 and 9.9 parts per million nitrate nitrogen. An additional 34% of the wells contained between 2 and 4.9 parts per million nitrate nitrogen. 31% of the wells contain between 0.1 and 1.9 parts per million nitrate nitrogen. And 14% of the wells contain less than a tenth of part per million nitrate nitrogen. So this is our distribution, and as far as safety is concerned, Pretty good numbers. Now you can look at this data and you can interpret it many different ways. If you were to release this table to the local media, you could probably get 5 or 6 stories. The first story, and every story would be scientifically valid. First of all, based on the Idaho Farm Bureau wellhead survey, 94% of the wells had nitrate levels that were considered safe for human consumption, because only 6% of the wells were above the EPA standard. Another person could write an article saying that 86% of Idaho's wells are contaminated with nitrate, with only the 14% of the wells that contain less than 0.1 part per million. I guess that would also be logical based on that. One of the big questions we had, and it was argued among state agencies and federal agencies about this survey, is what is a background or what is a natural level of nitrate nitrogen that you would assume should be used in Idaho wells? Should it be 0? Should it be anything less than 10 parts per million nitrate nitrogen? Pretty controversial aspect. To take a look at some of the existing data, scientists looked at well samples for nitrate values in wells that basically were untouched by humans throughout the western United States. For instance, a few wells in Yellowstone National Park and areas like that. And the agencies finally agreed that a background level of nitrate nitrogen could be any value of 2 parts per million nitrate nitrogen or less. It is possible to have wells that have 1.6 parts per million nitrate nitrogen that are natural background levels because of geological materials and other things. Consequently, the agency set 2.0 as a value above which nitrate nitrogen levels indicated that there has been some human activity that have elevated nitrate nitrogen levels in groundwater above background. So let's take a look at the results on a regional basis in Idaho. If we split Idaho into 5 areas: northern Idaho, the mountains of Idaho, southeast Idaho, south central Idaho, and southwestern Idaho. Let's look at the north first. Here's a map showing the northern 10 counties of the state. The 3 counties in green were counties that participated in the Idaho Farm Bureau wellhead survey. That would be Bonner County, where Sandpoint is, Benawa County, and Latah County, where Moscow is. 142 samples were submitted by private citizens from these 3 counties. And if we look at the split, first of all, let's look at the percent of wells that had 10 parts per million nitrate nitrogen or greater. And that was only 3% of the wells. So 97% of the wells in the northern sampling area met federal drinking water standards for nitrate. If we look at the background levels, remember we're going to consider a background level of nitrate any value less than 2 parts per million. If we look at 37% and 39%, that's 76% of the wells contain only background levels of nitrate. So human activity had elevated about 24% of the wells to have nitrate values above background. Really a very good record. If we look at the mountain counties in Idaho, this is Custer, Butte, and Lemhi counties. All 3 counties participated. 212 samples came in. If we look at only 1% of the wells, basically only 2 wells, 2 of the 212 wells had nitrate nitrogen levels above the standard of 10 parts per million. And if we look at background, anything less than 2 parts per million, 68 and 14, 78, 82% of the wells had nitrate levels that were considered background. Very good. Not much impact by humans. We go to the southwestern part of the state. The southwestern part of the state had more samples than any other portion of the state. If we look at a map of southwestern portion of the state, all these green counties participated in the survey. That would be Owyhee County, Elmore County, Ada County, Canyon County, Payette County, Washington County, and Gem County. So we had a total of 1,206 well samples that were submitted by private landowners. If we look at the numbers here, 9% of the wells were above the EPA standard of 10 parts per million. That's pretty high for all the regions in Idaho. The highest percentage of wells above the 10 parts per million standard, 10 part per million nitrate nitrogen standard, were found in southwestern Idaho. If we look at background levels, 41% of the wells had nitrate levels that were just background. So you could see that southwestern Idaho was a hot spot, and 9% of the wells above 10 parts per million is something to be concerned about. Yet that's not nearly as bad as a lot of Midwestern states where you're seeing 15, 20% of the wells above the 10 part per million standard. There are several reasons for the relatively high nitrate levels in southwestern Idaho. The first reason is that this is an intensive agricultural area on the Snake River Plain. Lots of many different crops are grown, and lots of nitrogen fertilizer is used on those crops. The second reason, and it's probably more important than the first reason, is that the depth to the water table is pretty shallow. The water table is pretty shallow in many of these counties. There are places where the depth to the water table is only 3 to 4 feet. So it's very easy to leach nitrate into the water tables. And this is particularly true in counties like Washington County and Payette counties. We go to south central Idaho. In south central Idaho, we had 4 counties that have participated in the Idaho Wellhead Sampling, Farm Bureau Wellhead Sampling Survey. 541 samples were brought in. Samples came from Cassia County, Twin Falls County, Jerome County, and Minidoka County. The numbers showed that 4% of the wells were above that 10 part per million nitrate nitrogen standard. And if we looked at background numbers, only 21% of the wells were at background levels or less. So you could see well over 3/4 of the wells had some impact of humans, and that's meaning values of 2.0 or more. And then if we look at the 5th region in Idaho, we look at southeastern Idaho, turn of the century in the state. Now, we have regulatory agencies in Idaho that also do groundwater monitoring, and they test for nitrates. They do it on a more statistical basis. They would say that their numbers are more valid because their sampling is set up so their sampling is not skewed. And if you take a look at the state ambient groundwater monitoring program, it showed that 3% of the wells exceeded the EPA nitrate nitrogen drinking water standard. So the state monitoring showed fewer high nitrate values than the Farm Bureau monitoring. And that's because the Farm Bureau monitoring was skewed to counties and to farms where nitrate might be more of a concern, and those people brought in their samples. Also, the state regulatory agency monitoring program found that about 1/3 of the wells had been impacted with nitrates, which means the nitrate nitrogen values were above the 2 part per million nitrate nitrogen standard, meaning humans had activities that had elevated nitrate levels. Most of the water was still safe. It wasn't a problem. So our next thing is, in the last lecture, in lecture 5, we had talked about what would be different sources of the nitrates getting into groundwater. We talked about agriculture, we talked about septic systems, we talked about animal waste and things like that. Well, using radioisotope materials, the state has a good idea The state government has a good idea where those nitrates in the groundwater came from. Based on good scientific research, about 60% of the nitrate nitrogen found in groundwater comes from fertilizers. An additional 22% comes from mineralization of animal waste. Another 11% came from legumes. The atmosphere was considered to provide maybe about 5% of the nitrate that reached groundwater, and septic systems were considered to contain about 2%. This table is important because it gives government and local officials information about where they should concentrate on trying to protect or try to protect nitrates from leaching into groundwater. Looking at this this table again, 82% of the nitrates in groundwater are coming from the agricultural arena through the use of fertilizers or manures, and then the legumes, probably another 11% here. So that's where a lot of concentration a lot of emphasis needs to be made if you want to prevent nitrate nitrogen levels from increasing in groundwater. One of the things we do have in Idaho is because the regulatory agencies have been not monitoring nitrate values in groundwater for a long time. Within each aquifer, there is some good data that shows the trends, whether nitrate values are increasing or decreasing or staying the same over time. Okay, we go back to the nitrate areas of concern, which I introduced in the last lecture. Again, we said there's some place between 25 and 33 nitrate areas of concern. When the publication you're taking a look at was written, there were 33 nitrate areas of concern. Today, there's somewhere between 25 and 26. All of the geographic areas are still of concern. It's just that some of the aquifers have been combined. Instead of saying this geographic area was two different aquifers, they combined it into one big aquifer. A nitrate area of concern, legally speaking in Idaho, is an area where 50% of the wells are above 2 parts per million nitrate nitrogen, which means half the wells sampled on that aquifer have nitrate nitrogen values above what is considered background levels. And or 25% of the wells in that geographic area are above 5 parts per million nitrate nitrogen. Now, we haven't said anything about the percentage of wells above the EPA federal standard of 10 parts per million. We're talking about higher than background levels of nitrate nitrogen. That means there are certain management practices within that geographic aquifer where humans are contributing to a nitrate increase in groundwater. And the vast majority of time, the nitrate levels in this groundwater are still safe. Here's a look at Idaho's areas of concern. Again, we started out with 33, and we're down to 25 or 26 just because some of these aquifers have been combined. If we take a look at the state in general, if you look at southwestern Idaho through south central Idaho, these are aquifers along the Snake River Plain, where we have a lot of people living and we have a lot of agricultural activity. Very few in northern Idaho, 3 aquifers, and there's a few scattered aquifers in the southeastern part of the state. And if we just take a look at a couple aquifers in a little bit more detail, I just pulled a couple off of here randomly. Let's take a look at southeastern Idaho. Again, the red areas represent the nitrate areas of concern. And you can see that you're talking about the Pocatello area. This is the Ashton area. We'll take a look at this one first. This is Mud Lake. And if we zoom in on Jefferson County here, This is a nitrate area of concern, nitrate area 25 or 28, I can't remember the number. But anyway, if you've ever driven on the highway through Mud Lake, you know that Mud Lake is an area where they grow a lot of alfalfa for animal feed. A lot of irrigation goes on here, so a lot of nitrate that's liberated from the plants and things like that can leak into the aquifer. So the Mud Lake nitrate area of concern, they found that 62% of the sampled wells had more than 2 parts per million nitrate nitrogen in the water, which means 62% of the wells, more than 62% of the wells, had nitrate levels that were elevated because of human activity. So 62% of the wells above 2 parts per million, and half the wells, over half the wells, were above 5 parts per million nitrate nitrogen. So there's definitely an upward trend here, definitely some management practices that were causing nitrate nitrogen levels to be high. 6% of the wells were above 10 parts per million, so 6% of the wells were outside the EPA drinking water standard if you were going to use the water from these wells for drinking. So, overall, 94% of the wells are safe, but officials and locals did not like the fact that a significant portion of the wells had elevated nitrate levels, which means some types of human activities had caused problems here. If we take a look at another area in southeastern Idaho, if we take a look at the Ashton area right here is an area where we grow a lot of seed potatoes in the state, and it's considered one of the 3 aquifers we're most concerned about with elevated nitrate nitrogen levels. If we overall look at the data from southeastern Idaho, and we look at the acreages, the Mud Lake aquifers over 36,000 acres of land in this aquifer, about 6,700 acres in the St. Anthony aquifer, about 34,000 in the Ashton area aquifer, and 106,000 in the Teton areas, and another 10,000. So you add those up, and that's quite a bit of land that people are living above that may be impacted by how they use or how they manage their property in the future because of elevated nitrate levels. One of the key areas in southeastern Idaho, you can see this is Highway 86 right here. As it's moving toward Pocatello. Here's Pocatello. Idaho Falls would be north of the map. One of the areas of concern is the Fort Hall area. The Fort Hall area is an elevated nitrate area level, and it's an area that is farmed, a lot of potato land. The reason why the nitrate levels are elevated are farming practices, but primarily these soils are very sandy, and it's very easy to leach nitrate into the groundwater in this area. We have other areas in southeastern Idaho aquifers where a significant portion of the wells are above background levels, above the 2.0 parts per million nitrate nitrogen values. This would be in the southeast of Pocatello, the Cache Valley, the same thing. So if you look at the southeastern part of the state, you start adding up the numbers. The Cache Valley, 129,000 acres. Other southeast aquifers, about 309,000 acres. The Portneuf Black Cliffs area, a small aquifer, 2,500 acres. The Pocatello-Chubbuck area, about 10,000 acres of land. And Fort Hall, about 32,000 acres of land. And remember, the soils in Fort Hall are pretty sandy, and they grow potatoes on them, so it's very easy to leach nitrates. So if we look at southeastern Idaho collectively, there's about 695,000 acres of land that are geographically included in these nitrate areas of concern. Within this 700,000 acres, 77,000 people live. They may be impacted because management practices are going to be encouraged that reduce the chance of nitrates leaching into the groundwater. Let's go to south central Idaho. Again, we've got just a few aquifers here. We've got 4 aquifers in this region. This is Twin Falls, the Twin Falls aquifer here. This is Cassia County over in the right. And we separate the aquifers at the Snake River. In Cassia County, here's an aquifer. And north of the river is an aquifer in Minidoka County. And then we have a little aquifer over the west. I believe it's Gooding County. The Twin Falls aquifer is one of the 3 major aquifers of concern in the state, and that's because we're seeing elevated nitrogen levels. You've got a large amount of towns and people living here. In addition, this is all heavily irrigated farmland. We move a little bit to the east, and you have the aquifer in Cassia County, south of the Snake River, and the aquifer in Minidoka County, north of the Snake River. Very intensive farmland here, and you have a lot of communities. And around the Snake River area, the depth to the aquifer isn't that great. So collectively, if we look at south central Idaho, about 540,000 acres of land and 85,000 people living within this area. Then we go to the southwestern part of the state. There's lots of aquifers in southwestern Idaho. They aren't quite as big geographically as they were in south central Idaho. A lot of these aquifers have been combined as far as governance is concerned, and that's what has reduced us from 33 nitrate aquifers of nitrate areas of concern down to 25. So you can see in the western Treasure Valley, aquifers in Canyon County, Owyhee County, Payette, Washington County, all of these areas. The aquifer number 4 here in Washington County is considered the most vulnerable area in the state. We actually have high nitrate levels in a significant area of this aquifer. And the other problem is the depth to the groundwater table is it's a very shallow depth to the groundwater table, and we grow some intensively managed crops that use a lot of water. So collectively in southwestern Idaho, there's about 435,000 acres of land within these geographic nitrate areas of concern, and that would include well over 320,000 people. We go north, and there's 3 aquifers that have a significant portion of the well samples above the background level of 2 parts per million. That would include aquifers here at the edge of Latah and Nez Perce County. We call that the Genesee aquifer. An aquifer here in Nez Perce County, and here basically up on the Camas Prairie. Collectively, about 220,000 acres, and only 2,100 people live above these aquifers. So if we take a look at nitrate areas of concern based on population distribution, the people that are most impacted are the people that live in southwestern Idaho. 2/3 of the population that lives on top of nitrate areas of concern live in southwestern Idaho, and very few of them in northern Idaho. The acreage distribution, pretty evenly distributed across the state. About 37% of it is in the southeast. 28% of the land in these aquifers is in south central, 23% in southwest, and 12% in the north. What are the implications if you live in a nitrate area of concern? Implications can be very mild to very strong in the future. So if we put together a scale and we look at implications of living in a nitrate area of concern, and let's say you're a landowner, the implications can be very mild. You have high levels of nitrates above the 2 parts per million. An educational program. Let's educate people on best management practices that would prevent nitrate from leaching into groundwater. Education is always the first answer. Let's say we have higher levels of nitrates in the groundwater. Well, that's when agencies step in and say, we have some cost share programs that landowners can institute to reduce nitrate leaching, changing in management practices, and we'll pay part of that cost because this aquifer really benefits a lot of people. Higher levels, we should have nutrient management plans. People may need to account for how they use their nitrogen, justify how much nitrogen they use, when they apply it, how they use it. That's getting to a more severe implication. And then, maybe we need nutrient pesticide management plans. In most cases, across these 33 nitrate areas of concern, we're talking about best management practices education programs right now. There are a few cases where we have nutrient management plans that are specific for an industry. We'll cover them in a few minutes. But from an implication standpoint, we're still up here educational programs. And that's primarily because, only 3% of our wells are above the federal standard for nitrate nitrogen. It's not as serious a problem here in the Pacific Northwest as it is in the Midwest and in the South. We have some areas of the country where things are much stricter. We can go to Maryland. Nutrient management plans are mandated by law on all farms that have receipts that are greater than $2,500 a year. And when we talk about a nutrient management plan in Maryland, the landowner has to account for their manures. What's coming onto the property, what's leaving the property, how the manures are used. Biosolids, they have to account for that in their nutrient management plan. They have to account for fertilizer use, what they buy, what they apply, when they apply it. And these nutrient management plans have to be kept current. They have to be updated every 3 years. If we go back to Idaho, an example of a nutrient management plan is that the people that own dairies are required to have a nutrient management plan on their dairy right now because so much manure is used. How is that manure used? How is it accounted for? Where is that manure placed for disposal? Also for beef cattle, confined animal feeding operations, and dairies as well, nutrient management plans are needed. Right now, there's no plans for people applying fertilizers to crops. That may come in the future if nitrate levels continue to increase in certain aquifers. Not saying they are. It's unclear if they're increasing, staying the same, or decreasing. But if they were to increase, maybe the next step would be nutrient management plans for people growing crops. We haven't talked about pesticides, but we know that pesticides can leach and get into groundwater. Most of the pesticides aren't as leachable as nitrates, but we do have areas of the state where we have pesticides in groundwater. So there are some implications for plant protection programs. Again, from a mild case, best management practice education, which would be integrated pest management programs, then step up to cost share programs, then step up to nutrient management plans where integrated pest management would be included, and then having integrated nutrient pest management plans. If we look at strategies here in the Pacific Northwest, again, I'm using Idaho for an example, but many of these strategies are the same in Washington and Oregon. Our strategy, elevated levels of nitrates in groundwater, let's educate people about best management practice. And different levels of government have responsibilities for different things. When we talk about best management practice education, we're talking about University of Idaho Extension. We're talking about the Idaho Soil and Water Conservation Commission, and we're talking about local soil and water conservation districts. The Idaho State Department of Agriculture has a statewide pest management plan. They also regulate things such as backflow prevention, so that we don't suck chemicals down into the groundwater. They're responsible for licensing, and they inspect. So we have BMP education, and we have certain things that are regulated. People have to have licenses to apply pesticides. Different things are inspected. And training programs under the auspices of the Idaho State Department of Agriculture. We move up a level. We move to the USDA, United States Department of Agriculture. They have programs that encourage wise use of resources, programs that discourage nutrient and other chemical leaching into groundwater. And sometimes to implement these programs, they actually cost share with landowners to put these techniques on the ground. The Idaho Department of Environmental Quality, they have authority under the Clean Water Act. And there's a groundwater section of the Clean Water Act, and this gives them the authority to regulate things or pollutants that are involved with groundwater. We have other things that indirectly affect groundwater. DEQ, Department of Environmental Quality, the Idaho State Department of Agriculture, and the Environmental Protection Agency collectively regulate wastewater. If a lot of people want to dispose of their wastewater on land, they issue land application permits. They regulate how animal waste is disposed of. And in addition, they regulate septic systems. Usually that goes through the health district at the local level. And they have stormwater programs. Remember, stormwater runs off city streets. That can enter groundwater, so it can be a groundwater pollutant. In the 1980s and early 1990s, when we talked about water quality in the Pacific Northwest, we talked about surface water quality. We talked about streams, and we'll talk a little bit about this when we get into surface water quality. We had TMDLs, total maximum daily loads, levels of pollutants that streams could tolerate while still meeting their designated beneficial uses. Well, today, groundwater is just as important as surface water, and chemicals like nitrates have become just as important, equal importance. The nitrate areas of concern that I have briefly mentioned in the past two lectures could have an impact on agricultural practices. Someday, if you geographically live in one of these nitrate areas of concern, you may have some standards that you have to meet about using fertilizers as far as how much nitrogen you can apply, when you apply it, and disposal of animal waste. Nitrate areas of concern, it's written for nitrates, but it's really groundwater vulnerability. Nitrate areas of concern may impact plant protection. Any pesticide we use on agricultural land that's leachable basically is targeted by these nitrate areas of concern. So in the last two lectures, I've tried to give you an update on one of the many pollutants that can get into groundwater and what framework is there what's the logic behind the framework of trying to reduce nitrate levels getting into groundwater, and some of the strategies out there that are being discussed. Thank you for your attention. Small, but all the counties in green participated in the survey. 480 samples came in from this area of the state. 3% of the wells were above the 10 part per million nitrate standard. And if we look at background levels, 61% of the wells had only background levels of nitrate nitrogen. So this gives us a really good historical basis for what nitrate values look like